Mr. Moore's math class! Good afternoon, guys, and welcome to Mr. Moore's online flute classroom. And boy, am I excited today because I am back. That's right, it's been a few months since I've made my last video, and some big news, by the way. In the last few months, I've just passed my 1,000 subscribers, and apparently I have to do a big thank you video to all my new subscribers, so thank you, especially to all those students who I forced to subscribe to my channel. Very nice of you guys to stay on board. Anyway, guys, today's lesson is all about circular functions, because that's a brand new topic. Now, as part of circular functions, you've got to get used to this little guy that you're going to see here. That's called the unit circle. So let's have a look at a bit of a video about the unit circle and where sine, cos and tan come from. So let's check it out.
Well, hey there guys, now today we're going to have a look at this little bad boy here, and it's called the unit circle. Now what's the relevance of it? Well, you've actually been using stuff to do with this guy for the last few years. That's right, every time you've actually gone through and used sine or cos or tan, well, all of those come from this guy here. So, let's go through and have a look at it, shall we? Now, have you ever wondered how the calculator knows how to figure out sine, cos and tan? Well, even if you haven't, bad luck because you're going to learn it anyway. So, to gain the most from this presentation, you're going to need a calculator set to degrees mode, really important. You're also going to need to have a pen and also a copy of my fantastic notes that can be found on the portal. So, the unit circle is a circle with a radius of 1 unit. So if we have a look at this guy here, he's got a circle, or he is a circle, and the radius is 1 unit. That is, it's a distance from here to here of 1 unit. Now, we can use this to find out the value of sine theta, cos theta, or tan theta. And you're going to see this in a bit more detail as we go through the presentation. But first, we must label the axis. Now, the y-axis isn't going to be known as the y anymore. No. It's going to be known as the sine axis. So we're just going to write sine theta here. And the x-axis, well, that's what we're going to call the cos axis. So we're going to write cos theta here. So instead of having the y-axis, it's now known as sine theta, and the x-axis is known as cos theta. Now tan theta is equal to sine theta divided by cos theta. But we'll come back to this later on. We'll see it in a little bit more detail. Alright, let's now go through and name the quadrants, because that's pretty important before we go any further. So the very first quadrant is the one up here on the top right hand corner. The second quadrant is here, third one's down the bottom, and fourth one over the bottom right. So we've got 1, 2, 3, 4 working its way around in an anti-clockwise direction. So this is how it all works. Let's just have a look at the unit circle again. Alright, what I'm going to do is draw a line from the origin all the way out to the circle that makes a degrees of 18 degrees with the x-axis or the cos axis. Now, what that's going to tell us, or it's going to help us define, is what sine of 18 and cos of 18 is equal to. Because, let's have a look at cos 18 first. If I draw a line directly down from the point where it touches the circle, down to the x-axis or the cos axis, well, it's going to tell me what cos 18 is equal to. That is, it's going to be equal to 0.95, because of course we've got 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 0.9, 0.95. So therefore cos 18 is equal to 0.95. Now to find out what sine of 18 is, well, we draw it across up to the sine axis. So we go from this point here where it touches the circle all the way across the sine axis, and that's going to tell us that sine of 18 is going to be 0.31, of course. 0.1, 0.2, 0.3, just a little bit more than 0.3 is 0.31. Now you can actually check this on your calculator by just typing in sine 18 and cos 18, and of course you'll actually get those answers. So what I want you to do now is just press pause and just prove that to yourself. So go through and do that. Excellent, so now that you've gone through and that you've actually put in a sine of 18 degrees and cos of 18 degrees, and you got the same answers as what you saw when we actually used the unit circle, what we're going to do now is go through and explore this whole idea in a little bit more detail. So let's go through and do that, shall we? I'm going to draw a line that goes from the origin all the way up to the circle here, and it makes an angle with the x-axis of 60 degrees. So let's now find out what cos of 60 is going to be. Well, to do that I need to draw a line going down here from where it touches the circle, and that's going to be roughly at 0.5, so therefore cos of 60 is equal to 0.5, as you can see. Now to figure out what sine of 60 is, well, what are we going to do? Well, we come here and we draw a line going across to the sine axis. So therefore, the height of this point will be at roughly 0.5, 0.6, 0.7, 0.8, just a little bit more than 0.85, so it's going to be sine of 60 is equal to 0.866. Now, of course, if we actually went through and wrote this point here as a coordinate, it would be 0.5, 0.866, wouldn't it? So let's go through and do the next one. And that is if I draw a line going directly up from the origin to this point here at the circle, well, what is my cos value going to be? Well, at this point here, what's my x value going to be? And if I come straight down here, it's going to be, that's right, it's going to actually be 0. Therefore, cos of 90 is equal to 0. Now, if I figure out what sine's going to be, well, it's going to be at the very top point. So what's the sine value? What's your y value here? Well, it's going to actually be 1. So therefore, sine of 90 is equal to 1. Now, if you don't believe me, what I want you to do again is actually go through, press pause now, and actually attempt to put it into your calculator and see what pops up. So go through and do that. Excellent. So now that you've actually gone through and put in these values of sine of 90 and cos of 90, and you found out that cos of 90 is equal to 0 and sine of 90 is equal to 1 on your CAS calculator, let's go through and explore this whole concept a little bit more, but in quadrant 2. That is this quadrant over here. So what I'm going to do now is draw a line from the origin over to the circle here that makes an angle of 157 degrees with the x-axis here, or the positive cos axis, as you can see. So let's go through and figure out what cos of 157 will be. Well, if I do that, I'm going to draw a line down, as you can see, from this point where it touches the circle all the way down to my cos axis. Now what's that going to be? Well, it's going to be roughly negative 0.9 something. So what's it going to be? Cos of 157 is equal to negative 0.92, because of course, really close to negative 1, but it's not quite, so it's negative 0.92. Alright, let's figure out what sine of 157 is going to be. So to do that, I start here and I draw a line all the way across to my sine axis. Now what can we see here? Well, you can see that it's roughly at 0.4. Alright, so it's going to be sine of 157 is equal to 0.39. Now, of course, it's not 100% to scale this unit circle because I've had to move things up and the technology hasn't been 100% right, but as you can see here, it's pretty close to 0.4, and in fact, when you put on your calculator, sine of 157 is 0.39. So we go to the next one now, and that is sine and cos of 180 degrees. So I've got my line and I've drawn it all the way across here because my angle of 180 degrees will get to here. So draw my line all the way across the circle. Now what's cos of 180 degrees going to be? Well, it touches at this point right here at negative 1. So therefore, cos of 180 is actually equal to negative 1. Now what's sine of 180 going to be? Well, how far up is it? Well, if I go from here all the way across the sine axis, it's actually at 0. So sine of 180 is equal to 0. So once again, press pause and actually prove this to yourself on the calculator by typing in cos of 180 and sine of 180 and see what you get. Excellent. So now that you've gone through and put in the values of cos of 180 degrees and you got an answer of negative 1, and sine of 180 degrees and you got an answer of 0 to prove that once again this whole unit circle thing actually works, what we're going to do is explore this whole concept but in quadrant 3, and it'll become apparent why we're exploring in each quadrant very soon. So let's go through and draw a line now in quadrant 3, that is down here. And what it's going to do is make an angle with the positive x-axis of 237 degrees, like you can see here. So, what will cos of 237 degrees be? Well, we're going to draw it from here all the way up to the x-axis, and you're going to get an answer roughly of just above a negative 0.5, so therefore it's going to be negative 0.54. Now, in terms of the sine axis, well, how far up the sine axis is it? Well, if I come here and go across, it's actually not going to be up at all. It's going to be in the negative direction, so it's going to give us an answer of negative 0.84. So therefore, sine of 237 is negative 0.84. And of course, whenever you want, you can press pause and actually put these values into the calculator and see what you get. But let's go through ahead with the next part just to see what actually happens. So I'm now going to draw a line that goes all the way down here. Of course, it's going to give me a sine value of 270 degrees because that is, it goes all the way around from here to here, and a cos value of 270 degrees as well. So let's go through and figure out what sine of 270 and cos of 270 will be. Well, cos of 270, if I start here at this point and I go all the way up to the x-axis, it's going to be an answer of 0. So cos of 270 is equal to 0. But what about sine of 270? Well, that is, I'm going to get this line here, I go all the way down to the circle. Now, how far down is it? Well, it's at -1 on the sine axis. So therefore, sine of 270 will be equal to -1. And of course, once again, what I want you to do is press pause and go through and check this on your calculator to make sure that in fact it's correct. So go through and do that. Excellent. So now that we've gone through and proven to ourselves that cos of 270 is equal to 0 and sine of 270 is equal to -1 using our CAS calculator, what we're going to do is explore this concept once again in Quadrant 4. So let's draw a line now in Quadrant 4 that's going to make 321 degrees with the positive x-axis. That is, from here all the way around to here is 321 degrees. So what is cos of 321 degrees going to be? Well, what I want you to do is actually try and think about it yourself and try and figure it out, and also what sine of 321 degrees is. So go through, press pause and do that, and when you're ready, play the video so you can see exactly what happens. So, what will cos of 321 degrees be? Well, if I go from the point where it touches the circle here, all the way up to the cos axis, as you can see, well, it's pretty much equal to 0.78. So cos of 321 degrees is 0.78. Now let's have a look. What's sine of 321 degrees going to be? Well, I go from here all the way across like so. Now sine of 321 degrees is going to be just below -0.6, so you get -0.63. So sine of 321 is -0.63. Now what we're going to do is actually draw a line at 360 degrees. That is, it starts here, it goes all the way around like so to 360 degrees. Now what will cos of 360 degrees be? Well, if I have a look here, it's actually going to be at 1, isn't it? Because it goes all the way across to 1 at this point. So cos of 360 degrees is equal to 1. Now what will sine of 360 degrees be? Well, if I have a look here, how high up does it go? Well, it'll go across to the y-axis, it's going to go up 0. So therefore, sine of 360 is equal to 0. Now let's just have a think about this for a second, because I could also say that's the same for cos and sine of 0 degrees, because it's going to be the same line, isn't it? If I haven't travelled anywhere, so I don't go around any revolutions, I just leave the line here, cos of 0 will be equal to 1, and so will sine of 0. Alright, let's go through now and explore some further revolutions. So, to have a look at this, what we're going to do is actually draw a line of 378 degrees. That is, it starts here, it goes all the way around, and then it comes past the 360 degrees, the first revolution, to 378 degrees. So I'm back in Quadrant 1. Now, of course, what's cos of 378 degrees going to be? Well, it's going to be here, down to here, well, therefore it's going to be 0.95. What about sine of 378? Well, it's going to be all the way over to here, which is 0.31. Now, that actually is the same as saying cos of 18 degrees, which is what we did in the very first one, and sine of 18 degrees. So it's exactly the same thing once you start doing multiple revolutions. It's just the same stuff over and over again.